Hello everyone, this is How I Love Geometry. I'm Mr. Chang. This problem is from China. This problem, it looks like simple. I know it has a lot of ways to solve it, but I just want to introduce two ways. And now let's draw the sketch diagram. In triangle ABC, angle BSE equals 45 degrees. So we can get like 45 degrees, right? This is 45 degree, BAC. And AD is the height of the side BC. So this is 3, this is 2, and DC. So here is D. BD equals 3, DC equals 2. Find the area of triangle ABC. So regularly, if we know the height, if I know AD, it's easy. Or sometimes if you know this angle, and will make the problem easy because you will easily to find the height, use trigonometric, right? So, or you can know AB and AC, and 1/2 this side times for sine 45 degree. So now here we should find we should find different ways, right? And so it gives the information is about here is 45, and that, and I have an idea what to use the tangent. Why? If I say this angle is alpha, and the tangent alpha will be h over 3, and this angle, tangent of this angle, let me see, is beta. So, and the tangent beta is h over 2. So, they have the same, because if we can find h, then we will solve this problem. And what's the relationship between alpha and this angle beta? And this angle beta equals, we know 135 degree minus alpha, right? Because all the 3 triangles, sum of them is 180 degrees. This 45 degree just help us to get this. Now, if we use this relationship between them, we will build the equation about the h. Then we solved the equation and got the h. So I call this way 1 trigonometry. Okay. We know tan alpha equals h over 3, and tangent 135 degree minus alpha equals h over 2. Okay, we can use this. Important in relationship between them to find the final answer, because we can get the formula to, tangent alpha minus tangent alpha minus beta. So it means this h over 2 equals tangent alpha. So is tangent 135 degree minus tangent alpha, right? 1, then plus tangent 135 degree times tangent alpha. And we know tangent 135, this one equals sine 135 degree over cosine 135 degree. And if you're not familiar for this special triangles trigonometric value, we can use a unit circle to find all of them, right? 45 degree and 45, also 45 degree. And if I got a point P, and now this is cosine, let us say cosine 45, and this is sine 45 degree, then you will get easily to get this one is -1, right? That's my way to remember special triangles value. So it equals -1 minus tangent alpha is h over 3. Okay, and this is 1 minus, because this is -1 minus tangent alpha h over 3. So we will get how much? Negative, here is 3 over 3 plus h, right? And denominator is 3 over 3 minus h. Now we can use multiple crossing multiplication here and there, and 3 and 3, no. So h times 3 minus h, right? This times this one equals -2 times 3 plus h. So let us come here, and 3h minus h squared will equals -6, -2h. So we will get h squared minus 5h and minus 6 equals to 0. H minus 6 times factorization, h plus 1 equals 0. And we will reject this one, and h equals 6. So the area of ABC, finally we found this one. So is 1/2 times 5 times 6, so it's 15, right? Yeah, that's way one. And the second one, I just use the geometry way, pure geometry way. How can I thought about it? How I got this idea, a new idea? Because this is 45 degree, right? 45 degree, let me think about the 90 degree. Okay, let's draw the graph like this, right? They are not isosceles triangle. And I just got auxiliary line. I just another 45 degree. Here is the origin 45 degree. And why I got this one? Because this will be 90 degree. In a right triangle, we have the Pythagorean theorem. And this is 45 degree, 45 degree. So we can use the angle bisector theorem, right? So here is 3, here is 2. And we know this is the height. So first, if I let us suppose this is, here is A, here is B, here is C, here is D, here is E, and let us suppose BE equals X. Okay. BE is X, so we know AD squared. AD squared equals AB times X, right? I don't need this one. I mean AB squared, because I want to use x and this. AB squared equals BD is 3 times BE x. So we got AB equals square root of 3 x. X is and the square root. So first we got this one. And the square root, we got 3x. That's for AB. So then we will got AE, right? Because we can use the Pythagorean theorem, and I use the hypotenuse squared x squared minus AB squared minus 3x, right? And this is AC now is an angle bisector. So we know AE over AB, this side to this side equals this one, this, hold on for CE, that's x minus 5, right? This is 5, total is x minus 5 over 5. So we can get AE equals x minus 5 over 5 times AB. AB is and the square root of 3x, right? Now, that's AE. We can get AE, right? This AE must equal to this. Now we build the equation. So each side, I mean AE squared equals this AE squared equals this AE squared. So AE squared, I got x squared minus 3x equals, here is 25 x minus 5 times 3x, right? Oh, squared. X minus 5 squared times x. So 25x squared minus 3x equals 3 x, so 3x, right? 3x times x minus 5 squared. And we can factor out x, and this is x, so 25. Each side I just cancel x minus 3, and equals 3. Now this I will extend this x squared minus 10x plus 25, right? So 25x minus 75 equals 3x squared minus 30x plus 75. So 3x squared minus 55x plus 150 equals 0. According to the formula, I can get x equals 2 times 355 plus and subtractor. So 55 squared we know equals 30, 25, right? 30, 25 minus 4 times this one. 4 times 3 is 12. 12 times 115, so is 1,800 minus 1,800 is 1 to 25. This equals 35 squared. So we will write down 655 plus or minus 35. So we know this is x. X must greater than this 3 plus 2. Yeah, greater than 5. So when equals minus, we will reject. So 55 plus 35 is 90, right? 90 over 6. We know x is 15. So when we got x equals 15, then we will get this side is square root of the 45. And what's the height of AD? That's height h is square root of this squared 45 minus this 9, so is 36, square root of 36, so equals 6. We got AD equals 6. And the same thing, area of ABC, you will find 1/2 times 5 times 6. We got 15 also done. This way is a little more complicated, right? And so sometimes one geometry problem, we have a lot of different ways to solve it. I just wanted to pick up some simple one, and normally easily to get the idea, and it's simple. Okay, I hope you enjoy it. Thank you.